commercial, then technical parks, hospitality buildings, residential projects, and he has also handled many infrastructure, plannings and their education, project monitoring, and also he was advisory to the government of Karnataka and Confederation of Indian Industry. Currently, he is with Adarsha Group as Vice President Projects. With this, I want to hand over the forum to Rajgopalan. 1 minute, just I want to inform the members that any queries or anything, you please put it in the chat box. We'll take it up at the end. Then one more information from us is that from our ACCE task force, we had circulated the Google response forms, and today also we are posting it. Whoever has not responded, please fill it up and send it back to ACCE head office. That is one. Another one is today evening at 5:30 we have AGM, Bangalore Center AGM. I request all the members of the Bangalore Center particularly to please attend it without fail. Thank you. Over to you, sir.
Thank you, Mr. Srikanth. Thank you to ACCE for giving this wonderful opportunity to prevail upon an interesting topic on Priestess concrete. And this is being presented by Dr. N. Ram Prakash, who is an expert in this field and who has contributed to various technical aspects to the engineering fraternity. He has published various standards. He has been associated in publishing various standards with the Indian Standards Institution and the Journal of American Concrete Institute, USA. He has been very actively associated with the Association of Consulting Engineers, ICI, Prestressed, ACWC, and various other important governing bodies. He comes with a vast experience of project management, design and construction management of steel structures, concrete, Priestess concrete, shell and spatial structures. He has executed designed and executed various unconventional structures and buildings, which is of very great importance in this day. To his credit, he has been accomplished with the Limca Book of World Records in '94 for the design of the 88 meters diameter lamellar grid dome structure. And he has been recognized and felicitated at various conferences both in India and overseas. With this brief introduction of Dr. Ram Prakash, I would like to take you to today's topic of discussion about Priestess concrete. What exactly is Priestess concrete? Dr. Eugen Brasinet has been acknowledged as the father of Prestressing, and way back in 1904 onwards, he has attempted various experiments and features to develop this concept. Priestess concrete is a method of overcoming concrete's natural weakness and tension, and it can be used for producing various beams, columns, floors, bridges with long spans, which is not practically achievable with a normal reinforced concrete. The basic principle behind this whole prestressing is the compression force is applied to the reinforced concrete structure. And this whole thing, we tend to use high tensile steel cables, either in the rod form or in twisted tendons. They are clamped onto the member either before or after, and that's why there are two types of prestressing. They are called as either pre-tensioning or post-tensioning. Prestressed concrete refers to a procedure where the tensile rods are put in place first and tightened, followed by concrete pouring. The compression is applied after pouring the concrete using the bonds and tightened once the concrete is set and dry. The major differences between the ordinary and prestressed concrete is even without a load, the beam should be able to carry its own weight, and an upward force is created which in effect relieves the beam of having to carry its own weight. There are advantages with prestressing. Section remains uncracked under the service loads. It gives reduction in steel corrosion, increases durability. The full section of the concrete member is utilized, lesser deformations, and improves serviceability, increases the shear capacity, and provides improved performance under dynamic and fatigue loadings. With prestressing, we also achieve a higher span to depth ratio, due to which we are able to go ahead with very large span structures and bridges. This advantage has been utilized in various commercial buildings also for generating the flat slabs of having very large span flat slabs, thereby giving the maximum space utilization within the building. It has been very conveniently and suitably adopted for various precast constructions and for repetitive construction. It also comes with certain amount of challenges, limitations, like it requires a high skilled workforce and technology for implementation. It requires high strength materials. At times, the cost of the specialized equipment should be higher, and requires a very high degree of quality control and inspection. But the advantage overall is the and hence is being generally, the concrete, minimum grade of concrete is used for prestressing, prestressed concrete. For post-tension concrete members, a minimum grade of M30 is being recommended, and for pre-tension concrete members, M40 grade of concrete is recommended. And the maximum grade of concrete what people have been using is around M60 grade for prestressed concrete structures. The steel which is used has a tensile strength of 1860 MPa, and it goes up to even 2100 MPa in certain cases. The predominant difference between the conventional mild steel or the toss steel and the high strength steel what we use in prestressing is the carbon content is slightly more, ranging between around 0.6 to 0.85%. The permissible stresses in the tendons at the time of the initial prestressing should exceed 80% of the characteristic tensile strength. final Priestess, after allowing for the losses, shouldn't be less than 45% for the calculated insights. Some of the major challenges what we undergo doing this priestessing is there are certain losses in the priestess. Some of those losses can be classified as immediate losses and long-term losses. Immediate losses are basically the elastic shortening, the friction, and the slippage lines. While the long-term losses are due to the reef, shrinkage, and relaxation. With this brief, I request Dr. Ram Prakash to elaborate on the case studies what he has done with various buildings, what all he has faced, the design challenges and the execution challenges. Over to you, Dr. Ram Prakash.
Thank you, Mr. Rajagopalan, and thank you, Mr. Srikanth, for those kind words. I would like to thank at the outset ACCE Bangalore Center, Mr. Srikanth, Mr. Savina, and the committee members for this opportunity, and more particularly Mr. Rajagopalan, who is today's moderator. I should not fail in my duty to thank my gurus, Professor K.T.S. Iyengar, was my guide and guru, not leaving out my illustrious contemporaries and the participants, dynamic builders among them, Priestess concrete enthusiasts, prospective future Priestess imbibers, friends, ladies and gentlemen. In this proposition, I wish to cover the subject of Priestess concrete as encountered by me in the various situations and projects. The presentation, I have broken it into the following: the introduction, the preamble, parameters, case studies. Some case studies of mine, some of the national projects, some international projects specific with specific coverage in each of them, and finally the conclusions. Just to lay the groundwork, I would like to wish to address some definitions for the benefit of some of the participants who are uninitiated. As you know, concrete is a gigantic industry because it's used in construction more than any other material. The industry size alone means researchers are keen to improve how concrete is made from the carbon footprint of the furnaces, but scotch lime for cement. So in this case, replacing heavy, costly steel that can corrode inside of Priestess concrete segments. Structural concrete, as defined by American Concrete Institute, in part, structural concrete is one in which internal stresses have been introduced to reduce potential tensile stresses in concrete resulting from loads. That is structural concrete. And Priestess concrete is a structural concrete in which internal stresses have been introduced to reduce potential tensile stresses in the concrete resulting from loads.
Dr. Ramprakash, could you please expand your slide to full screen?
Yeah, I tried that. The way it happened is...
Sir, please press F5, sir.
I know that. Yeah, okay, sorry. I think it's coming on now.
Yes, sir.
Yes, sir. Thank you.
Yeah. Okay. Prestressing is an introduction of the internal stresses. The introduction of the internal stresses is called prestressing, and is usually accomplished through the use of tendons that are tensioned or pulled tight prior to being anchored to the concrete. Different types are there may be pre-tension members or post-tension members in prestressed members. Pre-tension members these are common in buildings, parking garages, etc. Include precast hollow core sections, T and double T sections, etc. Among the pre-tensioned members. In the post-tension members, they are in PT slabs, bridges, flyovers, etc. Just would like to put a preamble to today's presentation. You might have heard this before from me, but I would want to repeat it for the new participants today. Computers have taken over domains in projects in modeling, 3D, in sizing sections, in loading stipulations and combinations, in analysis and design, in detailing, in project management, in construction management, in drone supervision, etc. I was seeing skill deficits at one time continuously, then wished that all construction was like maybe 3D printing with robots. So this is when I started practice. I was wondering why, because I started off with 3D analysis and design right from the first day I started practice, because I thought all structures are 3D, whether you like it or not. So then I was wondering why the execution is not what can be in a computer. So, but right now it's not yet there, but it's getting there. You know? So, but will it be as human as now and enjoyable, or a product mix of the two, hopefully? So once you have drones and you have robots, I don't know whether it will be as enjoyable, but it's left to us to make it enjoyable by our creations. Finally, this presentation is not meant to be a treatise, but a feedback of machinations of perpetuation in the built environment from the pangs encountered. Once patience runs out, as you go on educating people in your projects, rather than getting delivery from them. Now, for the benefit of fraternity, I've made this presentation. In case any course corrections can be made, and if any is required, that can be thought of by all of us. I have taken some of the projects which are going to be covered here. This is an industrial building, industrial project. This is a car showroom with cars stacked on all the floors. This is a double height basement of a sports complex with 6 tennis courts on top. It's like that. Other than this, I have other projects also. Now let's see the parameters that are involved in prestressed concrete. Prestressed concrete is a form of concrete where initial compression is given in the concrete before applying the external load, so that stress from external loads are counteracted in the desired way during the service period. This initial compression is introduced by high-strength steel wires, strands or cables called tendons located in the concrete section. Why is prestressed concrete required? We know concrete is good at compression but very weak in tension, and so we see after external loading in the bottom part of concrete, a tension zone occurred, so it tries to be elongated till it cracks. This is why we add some steel bars at the bottom so that it can resist most of the tension and save concrete from cracking. This is our traditional RC structure. But what about some mega structures with large beam spans? Think about a bridge, a flyover, a long span, highly loaded beam. Even a long span, highly loaded beam, like what it was in my case for this particular sports complex. Herein comes this concept, that is the prestressed concrete concept, stands in very well for this. This development started in 1886 and took off in a big way after the Second World War. Many of the persons who developed this are famous persons like Prestressed, Thereon, Cables, and others. The concept of prestressed concrete is not so difficult. In fact, the practice of prestressing things is very much older in our day-to-day life. Imagine a barrel made of wooden staves and metal bands. This is the simplest thing you can think of, which is related to even structure. The principle of prestress is the basic principle of prestressing was applied to construction perhaps centuries ago, when ropes or metal bands are wound around the wooden staves to form a barrel which was containing some liquid had to be strengthened, and this was one of the ways of strengthening. When the bands were tightened, they were under tensile prestress, which in turn created compressive prestress between the staves and enabled them to resist hook tension produced by internal liquid pressure. In other words, the bands and the staves were prestressed before they were subjected to any surface loads. Now, if you introduce prestressed concrete, initial compression is given to be balanced by future loading that will create tension. So when you do the prestress, it may camber upwards. Then when the load is applied, it may come into normal position. How does the prestressed concrete work? High tensile steel wires are inserted into the beam section and they are stretched and anchored, then released. Now the steel tendon wants to gain its original length, and tensile stresses are transformed into compressive stresses in the concrete. That's the beauty of prestress. The whole section can be in compression before any tension is imposed. Now, after loading, there are two kinds of forces in the beams: the internal prestressing forces and the external forces, which are the dead load and live load, etc. So what are the different types of prestressed concrete? According to the construction method, there are three kinds of prestressed concrete. One is pre-tension concrete. The second one is bonded post-tension concrete, and the unbonded post-tension concrete. Bonded post-tension and unbonded post-tension. In the pre-tension concrete, wires or tendons are tensioned at first and concrete is poured later. It creates a good bondage between the tendon and concrete. As a result, the tendons are protected from corrosion and tensions are transferred directly. Tendons are anchored and stretched, and the stress is transferred to the concrete when it is hard. Then the tendon tries to get back to the original length but is resisted by the bond between it and the concrete. Hence, it induces compressive forces in it. The second type is the bonded post-tension concrete. Similar processing is applied, but here concrete is poured first, then tendons are tensioned. Tendon is kept inside the concrete and then they are tensioned after. Tendons are placed at suitable places in the member and then casting is done. Now that gives you a lot of leeway to design biaxial prestress, triaxial prestress, and things like that. So tendons can be in different directions according to the requirement. After the concrete becomes hard, the tendons are tensioned by hydraulic jacks against the concrete. When the tendons have tension sufficiently according to design, they are fixed in position. After the jacks are released, tension remains and it transfers pressure to the concrete. This method is widely used in building monolithic slabs for mega house construction projects. You could see one of the views here. Next we come to the third type, which is unbonded post-tension concrete. It is unbonded, so it is not bonded to the concrete. It is little different from bonded post-tension concrete. It allows freedom to move the cables within the interstices that is available. For this, each tendon is coated with grease and covered up by plastic. Stress transfer to the concrete is achieved by the cables through anchors. There are some advantages to this, like the ability to distress tendons before trying to repair work. You can de-stress the tendons and do some repair work and then stress again. The ability to individually adjust the cables. You can adjust the cables according to any pattern required. What are the advantages and disadvantages of Prestressed concrete? Prestressed concrete is the most durable, reliable, and the strongest concrete that is wisely used for the construction of mega buildings and bridges. Herein, I would like to say that when I was in my bachelor's, my dream was to specialize in Prestressed concrete. When I entered my master's, my dream was to continue in Prestressed concrete because of this. Because we are dealing with a more durable product which is reliable and one of the strongest concretes, because even the concrete strengths are high. And you can go with a large span and things like that. I used to see in the books, but never see them around. So I was thinking that this is a subject that I should. Prestressed concrete has made significant contribution to the construction industry, the precast manufacturing industry, and the cement industry, because we are also getting high strength concrete, even that benefits the cement industry. Now, advantages of Prestressed concrete: longer span length increases untroubled floor space and parking facilities. As you will have noticed in many of the car parking facilities, more abroad than in India. Of course, it's also coming up in a big way in India. You have large spans, very bold spans. Thinner slabs that are important for high-rise building, as with the same amount of cost, it can construct more slabs than traditional thicker slabs. Many a time I say that you have to work out an alternative in Prestressed concrete for any of your projects before you conclude which is more suitable or more economical. As the span length is larger, fewer joints are needed than traditional RC structures. Because of fewer joints, maintenance costs also become reduced during the design life, as joints are the major focus of weakness in a building. Then you also have long-term durability because of the superior concrete, and then you have better finishing of placed concrete because it is also high strength concrete, and also it has a lot of additives which can help you in it. It requires a smaller amount of construction materials. I will come to it when I'm talking about the application and some of the projects which I had. I had interesting view on this. It resists higher than normal RC. Its resistance is higher than normal RC structure and is free from cracks. If properly designed, Prestressed concrete can be free from cracks and be the most suitable in certain situations. Now, what are the disadvantages of Prestressed concrete? Why I'm stressing on these factors is you have to have view about all of this before you enter into any domain, especially Prestressed concrete, because you are dealing with a different product and a special product, so it needs special care. Okay, let's look at the disadvantages, if any. Following are the disadvantages of Prestressed concrete. It requires high strength concrete and high tensile strength steel wires. So you not only put high strength but also put high tensile wires and make use of both of them in combination to give you whatever you want with respect to load or span. The main disadvantage is construction requires additional special equipment like jacks, anchorage, etc. Many a time, Prestressed concrete has not been pursued because people do not have access to the mechanical people in their group. So to them, the jack and the anchorage and things like that are a different subject, and it is not their domain. But over the years, with people who have got the zeal, they have mastered the art of the jacks and the anchorages that are available. And Prestressed concrete requires highly skilled workers under skilled supervision. Yes, if you want to do anything, you are doing everything which is slender, which is thinner, and things like that. So obviously, when a thing is slender or thinner, you should have skilled workers and skilled supervision. I want to repeat once again, skilled supervision. That's the key factor in any construction, but more so in Priestess concrete. Construction cost is a little higher than RC structures. Now, I've got a comment on this also when we come to our case studies. We have this bug in our mind that construction cost is higher and things like that. As I said just now, many times it is always wise to make the alternative, even though you have to go the extra mile, to make the alternative and take a call on this particular aspect. Now, straight away we get into the case studies where I can tell you some of these factors which have to be kept in mind. First was, as soon as I finished my bachelor's, I was in a designer's office and I got 2 bridges to be designed. That was the first project that I got. This 2 bridges project was my first Priestess foray after graduation. Involved in one of these bridges, it involved protracted debate which was going on with the peer reviewers. You see, it always happens that we don't agree with each other very much. And more so when you are dealing with something new or different as thought of in those days. So the peer reviewers had a view that the fixity assumptions of the cross girders, which was in this particular bridge, the fixity assumptions, they were not agreeable to. They would not want 100% fixity or 0 fixity. Some people assume 0 fixity, some people assume 100% fixity. This would not be acceptable to the peer reviewers, obviously, because they have their own views. And an impasse followed. The project would have been stopped because they would not. Finally, I really got into it in a big way, thanks to the background I got in my undergraduate. And I was able to solve this amicably by talking about what is the thing that they want. If I said 2/3 fixity, they said 50% fixity or 0 fixity, we could bring a via media and say, okay, what will you accept? What is the real factor? And I took out the equations, differential equations, and imposed the fixity conditions, and then got the solution. This solved the solution by me was one of my most thrilling events to start with Priestess concrete. Then there was a project of 1,000 houses. The project came to me where they wanted to build 1,000 houses in South India. In this 1,000 house project, realized the serious reality of detailed approach. When you do a few houses or a few buildings is one factor. When you do a mass scale construction like 1,000 house or many blocks, say 10 blocks of ground plus 7 and things like that, you have to have a reality of the detailed approach that is required for it. I made a motto that if you save in one, you save in all. And the motto was like, if you are saving rupees 500 in one house, it would work out to rupees 5 lakhs in the whole project. In those days, I'm talking about 500 and 5,000 when I started practice. Okay, that's a lot of money for any person promoting. So I said, let me imbibe all the good things that are required to make these savings. And so I brought in a precast Priestess concrete system in roof, which would save 10% in the roof. Okay, so this was very attractive to everybody because 10% in 1,000 houses in the roof cost. But they said, where is it available and who is going to do it and things like that. So I said, I can show you where these are being done right now. Fortunately, it was done in a few places which I knew. So I said we could see in those places, and the contractors also have to get the hang of how you do this or how they do it. Then I knew of a project in Bombay where LIC housing was going on, where they were building some hundreds of houses. So I went along there, and we all went there, and we were looking at where it was using precast Priestess. But after a visit to both the LIC housing project in Mumbai as well as to precast factory in Bangalore, dampened on the state of affairs. Because in the LIC housing project, it was a job was given to a subcontractor, and I went to his facility. I found the broken and failed members were so large that I told the contractor, how come so many beams have failed and things like that? He said, "Ye sab hota hai sahab," he said. And I turned around, your this thing, what shall we say, loss or failure or accumulation of your failure is a hit on your loss in the project. In Priestess, you should put your effort to see that very few rejects are there. Any reject is a big loss in the economy of the particular project. And here I saw that they were looking at it just like the reinforced concrete and not looking at it like Priestess concrete. And obviously, they were not seeing the loss that was being worked out, and they were taking it in their stride. But when I went to the factory in Bangalore, one of the factories in Bangalore was said to be making Priestess sleepers and Priestess precast beams. I think they were T-beams, inverted T-beams and things like that. When I went there, I saw pathetic condition of the forms, and I said that this is not something which is going into us, because in those days we could not cast ourselves or do everything ourselves. If we had people who had the expertise or the inclination to do it, we would have cast it in the project itself. So in one project in Mumbai, large breakages has large losses to build up. In PSP profit is in the losses of members. You know, the people who are in Priestess concrete, they know that their profit is in the losses of members. And another in Bangalore, pathetic condition of forms. Important thing in Priestess is to have good forms. Then you have got good finishes and all the advantages accrue. Next project was a Priestess concrete optimized road bridge in Bangalore with the Windsor Manor group. This was a precast Priestess project. So it was a national tender, and we got among 4 national reputed Priestess concrete contractors turnkey jobs. So this was a challenge, and in those days, I used to take any alternate design as a big challenge and succeed in most of them. And this was one of the things that happened to me, and which made me so happy that I am getting into Priestess some way or the other. Here, the contractor was 200% receptive to innovations, quality, and change. There was perfect harmony in performance. The important thing in all this Priestess is to have a contractor who's very receptive to innovations. First of all, this is thought to be an innovation in those days and even today maybe. And the quality. You should have quality as his watchword. What? Sorry? Sorry? Any? Yeah. Quality was his watchword, and he was ready for change. If I wanted a T section or L section or inverted T, things like that. So it's a lot of teamwork that goes on, and perfect harmony in performance. Finally, doing exactly what is needed by the team, and this contractor was, I would say, up to it. And seamless design and execution. Once you finalize that it will be a Priestess concrete system, then the bridge design came into picture. Seamless design and execution with traffic disturbed on one day only, and that too for only 8 hours. So because it was pre-stressed and precast and quite slender, it could be that we could set them up in 8 hours for both spans. It consisted of 2 spans and things like that. So we disturbed the traffic only for 2 hours. Okay. I don't know how I'm doing. I'm doing okay? Mr. Rajagopal? Okay. Ourselves imbibed shell around here. Then I came to the factor there when we studied the project that it was on a sloped, that road is a sloped road. So we were wondering, but the interesting thing is that it's already also designed for tanks going on top. That was the interesting thing for me. People asking why it should be designed for, I was asking why it should be designed for tanks on top. So that is the condition that was imposed. So we said, okay, we do it for that. So this design was had to be optimized. Now, seeing the thing, I said if the piers are exposed and there are people going on the slope and big vehicles going on it, let alone tank, I said the piers will be affected. So I imbibed a shell around the pier as a crash absorber in sloping road approach. So I put a shell around it to save the pier. Then I got a lot of accolades from peer reviewers. Once you go on thinking of all the aspects, I think accolades come by themselves. The fourth case study is the Alliance Française building. Here we did the building, and we had visitors from France coming once in a while, say once in 3 months or 2 months or something like that, looking at our project and going and things like that, overseeing. The French overseers always commented on large sections and large steel proposed compared to French designs. So they immediately, the first thing they did was they said, why are these with such large sections of beams and columns, and why so much steel is there in the site and things like that. That intrigued me, and I said, what could this reason be? And immediately it occurred to me that the French we found the French using 60 grade steel those days and had Prestressed concrete on all members right then. Whereas here it was all reinforced concrete. So obviously it looked different for those people. This was really intriguing to me. So I said, I wish I had met these French before I made all the designs. They would have converted everything to Prestressed concrete, because that was the period which I was on, rather than do the same things like reinforced concrete and things like that. Then we convinced them of unavailability and prohibitiveness for use. As many of you know, many a time, as soon as you go to another agency to do the job, especially Prestressed concrete maybe, immediately you find that it's prohibitive, it has its own costing, and it may be that there will be very few people, very few players available to you. So some of them may not be available. In those days, I was told Priestess would be from Chennai or Bombay and things like that. And you get into all these particular things, and you have to go forward. Then, in this particular case, I proposed a Prestressed concrete roof. By that time, the building was coming up. I said these French have a point in what they're saying. Why not we put a Prestressed concrete roof for the auditorium, which was 55 feet by 100 feet. And I worked out with all the contractors, costly distinct steel and the Priestess and things like that. I calculated what the thing could be, and I found that we could make 10% saving in cost in the roof if you shifted over to Prestressed concrete. But the regular contractor was a reinforced concrete contractor, and we had to go for another Prestressed concrete contractor. So I found that the Prestressed concrete died a burial, as the RC contractor was forced to give 10% rebate in cost if he wanted the room, which he did. So the net result of all this operation was to bring the RC contractor down by 10%, which he wanted to do because he didn't want to bring somebody else into his project. So Prestressed concrete suffers incorporation by such offshoots. So I have today, that is, even if cost is same, change needs the change. Even if cost is same, and we have this inkling that we should save cost, and things like that. Even if the technology is of the same cost, I think we should imbibe a change in our systems. And I would have changed over to Prestressed concrete vehemently if I had had the opportunity. Towards this, I feel that all of us have a stake to purport change, so new inventions take us to next level, time and time again. All of us have stake in this. If we don't encourage Prestressed concrete, if we don't encourage any new technology, what is going to come up? Nothing is going to come up. It is not that you go on saving this or saving that. New technology comes, the technology may grow and save even further. So I feel very strongly that all of us are responsible for this, that very few players are available in Prestressed, or Prestressed is not imbibed, always cost, keeping an eye on cost, how much you are saving. Even if it doesn't save, I think we should have change in our systems and grow. I feel that I see this most of the places abroad, so we should have this too. Sorry. If you see the European model today, it is of nuances every day. So the European model today of nuances every day has taken them to new pastures of incorporation. This European model, I have seen, every time I see, you think of any invention or development, you find the European model already having worked on it available for that particular thing. So why is it so? It's because of the nuances that they imbibe in all the
video.
Hello?
20 minutes more, sir.
Pardon?
20 minutes more.
Okay. Okay, then we had a distressed cement silo in the cement plant in Tumkur. So I suggested they found some cracks, vertical cracks and things like that, and they called us for the study. I suggested circular pre-stressing in lower 1/3 height, for this particular thing, which is the ideal thing for silos. So alternative was steel belt strengthening was also worked. They wanted not only I wanted Priestess and they wanted the alternative. Some reinforced concrete. I said no, it has to be steel. So worked out the alternative. Latter got it. The steel got it as former coated double the latter. Anything you ask for new, people suddenly think all the problems that might come. They imagine all the problems and they quote higher. And Prestressed concrete never takes on. Prestressed concrete contractors in India play very safe and so lose contracts to reinforced concrete. This was happening once too often. Okay. Then there was a failed silo in Madhya Pradesh in a cement plant which was expanding. And so we asked players to come and do rehabilitation. I peer reviewed all the offers of the rehabilitation. Out of 4 submitted, only 1 was Prestressed concrete, rest was reinforced concrete. So this was a totally different ballgame. Picked Prestressed concrete solution of the French, as all others being artists. I found that the French deal with Prestressed concrete like as if it was regular construction. And their systems, procedures, and their workout was much superior to anything that was put up by the others. Sorry. Then their execution was like a treatise on Prestressed concrete work with not an iota of comment during execution. What I found in them was that they're not only good on the project workout, but they were also good at the execution. They were very, very apt in all aspects of execution, because in Prestressed concrete, execution is very important. Supervision of execution also. So I salute the French and Prestressed concrete after this experience, which was like the pinnacle of execution. So they have advanced to such an extent. Then I'm talking about a PT slab of a corporate building in Bangalore. I built PT slab in all floors of a 5-story building. Design of PT slab was said to be from a foreign proprietary software and not submittable and reviewable. When I had to review it, it was not going to be submitted, it was not going to be reviewed by anybody. It was not allowed to be reviewed. Then there was imbibing and integrating lateral load transfers at various floors was not imbibed in offer. They said it is not belonging to us. The PT slab people don't have to do the integrating of the lateral load and all that. We do only the slab. So it led me to ask them. Hence, their solution seemingly same whether it was 5 or 22 floors. So if you was given a 22-floor building or a 5-floor building as ours, would the solution be the same? There was no answer. Then gullible proposition of non-integration may result in serious failures. This is where there is a lacuna in all these aspects. Why do failures take place? Failures take place because of some of these gullible things where something is left in the lurch. Clear position to be mentioned in code and its commentary before any calamity takes place. This is one of the things that are badly required to be made clear, because the PT slab person says that the regular designer will take the lateral load, call on the lateral load, and he will take only on the places. Any such proprietary offers to be controlled more effectively such that failure is avoided rather than correct it only after a failure, because we are dealing with larger spans nowadays. Then we did a Prestressed, large span Prestressed beam and slab of a sports complex. As I said, tennis courts at top for the international school at Bangalore. So you could see the spans, and the spans were in the region of 75 to 80 feet, things like that. And these were all Prestressed. Change scenario, demanding large spans, imbibing advanced materials and technologies, handling the challenging situation of larger span in both directions and or heavier sections, larger braced staging result, high performance concrete manufacture, handling, placement, scheduling, work carefully, monitoring strength development, stressing with proper sequencing are the key factors. Releasing form work precisely. Sequence of release of the forms also is the key factor. Ensuring full of error-free, reliable grouting. That's a major thing that you do. So the synopsis of design for this project: post-tension beams and slab. It spans of 25 by 40 meter and 15 by 40 meter. Double-story high. PT beams flared at ends to accommodate anchorages. You can show that in the next slide. Okay. You can see in the next slide, you can see the flares at the ends of the beams. I flared the beams at the ends to accommodate. Otherwise, the Prestressed cables were, jumbled up there. The RC column free waffle slab. There was a portion which was a RC slab, which had a swimming pool. So we put RC waffle slab there. 6 tennis courts on top, and we used fiber reinforced concrete for the tennis court. So the innovation taglines are there for this project. Innovation taglines are: large spans are bridged with novel flat beams. Fiber reinforced concrete was used for the exposed tennis court. Exposed to weather, the tennis court concrete was exposed, deck was exposed. Has been useful to develop as column-free congregation area during assembly requirements. The offshoot was because of Priestess and large span could develop as something else. 5 foundations were imbibed to reduce unequal settlement problems. This is a key factor when you are talking about large spans. So keep this in mind. Said to be first of its kind among many surrounding states, if not in country. We kept asking the people whether they had done some Priestess of this kind somewhere. But in the same complex, we had an auditorium which was 60 feet by 40 feet or 18.3 by 12.2 meters. And I proposed a PT slab for it because it was an auditorium. Now the proprietary company gave a design with 2 beams made out of Priestess cables to result in 3 one-way slab panels to reduce slab thickness for lower level libraries headroom. So 2 beams were involved in the 60 feet direction so that this could be a one-way slab. Drawings vetted for execution. Everything was spick and span. All the drawings, designs, everything was peer reviewed by us. Were all ready. Then my assistant who was dealing with the project was shocked when priestessing was being carried out in circular fashion in periphery rather than as per sequence finalized and put in drawing. He went when the priestessing was going to be done to see what it is and whether everything is suitable. He found the priestessing people starting from this corner and going around like that, priestessing like that around the periphery. Then when they were asked, they said, this is what we do everywhere. It was a shock to him, so he said, you have to come to the site. I can't bear to hear this, or I don't know whether it's right or wrong. Then I had to rush out to the place, and then I told him, what is this? The sequence of priestessing was in the drawings, but not in the execution, which is a seal, especially when you had 2 beams, priestess beams, imbibed there. I hope these are one-off, but assistant said he won't believe so. I said this may be one-off in our project, but my assistant was vehement. He says he doesn't believe so. So no use having innovation imbibes if reality is going to be catastrophic. So once you get into innovations, you've got to concentrate on the issue, otherwise it will be catastrophic. Strongly suggest deterrent stringent stipulation on sequence of Priestess and its implementation by independent experienced agencies in order to save failures, as Priestess sections are stress sensitive. Even there was no supervisor for the man who was doing the stressing. He could stress whichever way he wants and go forward. Failure and rehabilitation thrive on such bloomers. So I've gotten into a lot of rehabilitation and failures. And all these happen because of all these backgrounds. What are the skill deficits found from all these case studies? Very few persons involved during stressing. Stressing is a very important factor, and very few persons are involved during stressing. And their level of knowledge is also not adequate. Sequence of stressing only in drawings was noted. Mechanic was caught stressing around the periphery. Lunch breaks, other breaks of end of day left to chance during stressing, nor recording it. So this sort of thing is not done in Priestess concrete. Any concrete is not done, but never in Priestess concrete. Very few persons trained for all this. Work left to uneducated mechanics without opportunity supervisors spying on their work continuously. Don't have practice of recording actions with respect to time, stressing values, etc. See, the supervisor is supposed to record all those things when every stressing and show it to the next level for approval. Prestressed is a fab system, but needs care. So you can see where the lacuna is in whatever you need to do. When something new comes along, this is not new, but even this is too much. Too much of interference and supervision is need of the hour with independent companies overseeing stressing and systematic grouting and recording. See, the need of the hour is to have independent supervisors or companies who look into those things. Now I come to some buildings with the heavy duty loadings and things like that, PT slabs. This was one of them. Made optimized economical 3D design with PT slabs. This was a high bay stores complex. It was racks storage racks were 8 meters high. So the loadings were very large. It was a traveling rack. Strongly suggested pile foundations, but was vetoed as there is a taboo by many in fraternity that is costly and should be avoided. So when I suggested that because of the PT slab, large span, and the differential settlement, and it should be only piles. The thing is, it's a buzzword, dirty word in construction. As soon as you say pile, they don't want you. They want you out of the project, or they want you away from the project. So this is funny. So I just said, okay, then we'll have a raft and we'll do a raft. Net result, a 6 months project got delayed by 2 months as a maze of service cables crisscrossed the area and no shutdowns were given so easily or whatever. So whenever you think of something, you get into somebody plugs it down and then the project suffers. And all I said was, you said so you suffer. That's it. Nothing for me. So they suffered the 2 month delay. Suggested PT slabs with reduced complications, heavy stage centering. Was surprised when the project manager of the A-class contract, the contractor who took up this job, supposed to be A-class, really A-class. And when I asked the A-class project manager, who was the quality manager, he said he is all in all in their project, which resulted in protracted quality issues in concrete mixes, reinforcement choices, etc. We had a PMC in this particular thing, but they were more like a post office, just sending things to me and back. So, they got to have more teeth. Then we had an industrial production building in the same complex. Building had column 3 production hall in 3 upper floors. All size were 20 meter by 15 meter. Loading, among others, was 7 turbo generators, 12 tons each on every floor. 7 turbo generators, 12 tons each. Said to be top contractor chosen was lax in quality planning and execution for multiple. Even if it is a class, don't be sure that everything will be A-class. Then we had to keep pulling up, come to it. Finally, PT slab, first roof, M35 concrete, we had stipulated, gave M33.2 and 33.8 in spite of his sourcing RMC from very big branded company. So no use to saying that I am buying from X, V, Y, Z branded company, so concrete is superior. This was a classic case of that, which was pointed out as not acceptable as per IS. So I turned around and said, this is not as per IS. So the RMC has to explain how they can send out concrete which is not as per IS. And then they wanted copy of the IS. And when I said this, I even sent that. I had the patient to send it. Requested next slabs to be sourced as M40. Obviously, you do design for bad construction if you go on like this. So for M35, if you want to give M40 and all that. But what I heard from the Priestess people was that they are using M25 also in some projects, which is calamity because of the stresses in the anchor zones and things like that. We are not doing the anchor zone separately. So then the contractor, we wanted to stop the job because the contractor said he would not do M40. That it would be admissible, some cement epoxy grouting with further cast slab, which he considered and said he'd get NDT test and prove his strength. Easy way out for everybody is to say I'll take NDT test and prove its strength and it will pass the test. The tube is all rotten and it is one off. Suggested that cement grouting was a must as it was PT slab and in anchor zone demand would be large. Once it went to an NDT group, they got 33.8 in the strength. But there is one clause in the code which says it can be divided by 0.85 or this can be taken as 85% strength and the real strength can be obtained. And so it went beyond 35 because it was divided by 0.85. And so they got a report saying that this is reasonably M35 concrete, which is a sad tale. Because I have never done Priestess less than 40 M40 concrete, and I had given M35 here, and I ruled the day. I decided on M35. Many a time, this is what you learn. Also, other floors, therefore, would be from same RMC. You would not want to go to any other RMC, which resulted in in-house furtherance in the project. Client was bothered of time delays if contractor was to be changed by retender. It's a sad tale of RMC companies sending out concretes which wouldn't be as per BIS. This is more important in precious concrete because of the high strengths that you are demanding. This was a car. Next was a car showroom with 2 floors in Chennai. With 2 floors PT slab I put in. So this is one of them. So I will skip this for lack of time. But this PT slab, the point is, add to these the minuscule contact surface areas of the vehicle tires. So when I browse through all the cables, my assistants measured the cable profile. They were not accurate at all. They were counting in inches where we were talking in millimeters, the profile. So we had to pull up. It was a very sad tale with respect to execution. And more so when you have a vehicle moving on it, with tire contact pressures very large. Okay, I had a flyover design, and we did the Priestess concrete flyover for BBMP. We prepared all the things, and 5 national tenders took place. We were L1, and we had a very sad pre-bid meeting where the concerned people, they were laughing at some of the questions without even seeing what the tender is telling you. Because in the milestones, the design check time was also involved. So when we asked how much time you are going to take to get the designs checked, they're asking, why are you asking about design checking? Then when we said force majeure clause is left out, they said, why do you need force majeure clause? We are not going to have a war. And things like that, So finally, they had a spite on us, and somewhere we were disqualified without a hearing. They took the easy way out by using their guts to disqualify us. L2 withdrew his tender without reason, and the whole tender was shelved. City lost a vital link due to such arbitrary approach. This was a vital link between Town Hall in Bangalore and Hudson Circuit. This was the project, and I had put together a great team of persons, including transportation and everything. Personnel at the helm, and those in authority have to show better knowledge, tender management, transparency, and seriousness of purpose, due to lack of which city and country should not suffer. Finally, the city has suffered. We don't have the flyover even today. Also, vital man-hours spent in tendering shouldn't go to naught. We should be compensated if they take out the tender, because all of us, there are 5 of us in the team, put in so many man-hours to this particular team. It can't be dealt with this year. Okay, now I'll come to a few. I think I'll need another 10 or 15 minutes. I'll just go through some of the case studies in the national sphere. One is the City Cycle flyover. It's the best of international standards brought into Bangalore. This was I think somewhere abroad. Such a flyover, I think it is not a flyover abroad. I think it is a causeway. But great. This is really the great thing to talk home about in India. The aesthetics were wonderfully imbibed. Construction was of best quality in standards and quality putting India on the international map. It was a winding road, and all of the engineers should go and see how they solved all those things. The camber in a winding road, the casting on those particular things. It was really saluting performance. Bad management and dealing of the local authorities derailed the project half the way. The project didn't go fully. It stopped at the town hall. Otherwise, it was supposed to go up to Hudson Circle. So you lose important people, innovative people, if you have bad management and dealing. Responsibility should be fixed for bad handling by the client of the professionals. If India wants to say it can be at par with international. It's easy to say we're all at par with the international, but we have to show it in action, show it in figures. Now the next case study I came across was when I went to Bombay and saw 55 flyovers. One of my partners was doing some flyovers in Bombay also. So they built 55 flyovers in 3 years. This is a sort of a record which every engineer should go. I went into in depth. I know everything about this particular thing. And I went and met the chief minister in Bangalore, Karnataka, telling him about this, that we should be doing this. And I don't want to tell you the experience. Any MHRDA project handling was impeccable and firm. Was the most comprehensive, practical, and effective in quality, system concept, and technology. Hats off to them. Tender documentation and implementation was made most simple and forthright. Must be taken as a shining example for all other flyovers to emulate and extend. This is one of the things I found. We have to throw up accolades on people who do such jobs, people who think this way. This is equal to any international foray. It is not only national. Okay? Finally, the national case studies, what I found is similarly in nuclear power plants, all facets of Priestess concrete are put to test, and hence enormous amount of quality standards, system concepts, and fail-safe methods have been tested and incorporated. So also in the Department of Space, each in its own way. Because everything has to perform in these places, and great opportunity exists for the challenging youngsters of today to show mettle has also changed. In each of the aspects, I found that in both these organizations, the youngsters are involved with all the discussions and all the concepts and the visions and things like that. So there may be somebody who throws up some nuances. Key factor is to perpetuate manuals for posterity and update them when necessitated, as is observed in these organizations. Another thing I found is that they have perpetuated manuals for different instruction, these which are handy for any employee there to take forward. Also, active involvement and participation in national code bodies lead to update principles and practices. Some of these people have to be actively involved in, and participate in the national code. Some people are only in name in many of the committees and codes. This is changing. This is active involvement is important. Intermingling, understanding of international codes and practices, and updating the national. So it's not only going through the national and being satisfied following it. You have to think of intermingling of international codes and what they are doing there and what could be better. Unified code internationally should be fostered. This is what I've been working for, and I know where it will come. The COVID pandemic has taught us by the imposed webinars to cross borders and have seamless interplay of precepts, practices, thoughts, and deeds. As I found that in some of the webinars, there were talk of somebody from, I think Middle East, somebody from Canada, and things like that. This should be nurtured even after. So some visions or some case studies from abroad, which I came across, and I found whenever I say to any client, I say whatever can be done anywhere in the world can be done in India. I want to satisfy myself that I'm saying the right thing. And when we see projects like this, imagine this is a catenary. Okay, this is a catenary, and these are all Priestess. So imagine all the machinery. We are talking about few beams and flyovers and things like that. Imagine you are given this project. I would wish hypothetically to work on such a project. Catenary concept with Priestess inclined columns, very futuristic and challenging, no doubt about it. Rare catenary profile, very rare to have a catenary profile in a shell. Effect of creep, elastic shortening, shrinkage, etc. very critical. One of a kind in the world is this project. Then in Singapore, I found that in the multi-story buildings, they have different things embedded in them. Prestressed. Many such multi-story buildings and structures have temporary stay cables in them for effects during construction. In Prestressed, stages of prestressing and stages of loading and things like that also come in. So they have temporary stay cables and things like that. Idle cables also. Also, progressive stressing of cables are also resorted to. They don't stress everything in one go and things like that. Progressive stressing in a building. Sometimes cables are removed at the end of the construction and they would have served their purpose in the interim conditions. Note all such imbibements for newer achievements. If you want to imbibe Priestess concrete, I think you should do that. And the other great thing is which I had ventured into in Bangalore, hyperbolic paraboloid shell roof on 2 columns, which didn't come up. But I see this particular thing and imagine that one day I wish I had done this. This is a hyperbolic paraboloid on 2 columns. They are built easily all over. I see this repeated in many places in the world. Large issues in Priestess concrete members are controlled impeccably. These are all Priestessed. So they controlled impeccably. Aerodynamic effects are sorted out with wind tunnel tests. Very easily they go to wind tunnel tests. Many times research institutions are on line with consultants and contractors. They are on line. Seamless integration of many domains like mechanical, aerodynamics, services, material technology, new and innovative forays are the order of the day. So in conclusion, I wish to say that unless we have a sea change in our approach to the following, Priestess concrete will not have its pride of place in India. Encouraging the young and innovative to try out Priestess concrete more freely so that affordable solutions spread across everywhere where it should. If you put Priestess concrete where it should, I think you would have done your job. But you should think more of doing more. Even if cost is same, change needs the change. Feel all of us have a say to purport change, so new inventions take us to next level time and time again. If you don't think of changes and imbibe them, what is going to happen? The development is going to go backwards rather than forward. The European model way of nuances every day has taken them to new pastures of incorporation. The other day I saw a windmill in Europe developed, which is horizontal and not vertical, and it has half the diameter and half the height. It's incredible what's going on. So it's all because of nuances every day. Quality system should be prima donna in the industry. Of course, there's no two thoughts on this particular thing, but more particularly for when you enter into some domains like research. Integration of all stakeholders to put PSC in the place it should be in. All of us have, I keep trying to see where I can put this Priestess concrete and things like that. We have many people, entrepreneurs start it and they close because of our attitude. We should be able to convince people, even if it costs the same, we should go for Priestess. That's the thought it should be. Interplay with international players and organizations will benefit the believer and the planet. So if you interplay with what is happening abroad, they are much ahead in Priestess concrete. So we all have a mission to accomplish, bring change, to give change a chance to survive and bloom. Say it again, bring change, to give change a chance to survive and bloom. Thank you.
Thank you, Dr. Prakash, to be on the dot. Appreciate it.
Thank you.
I'd like to share few of my experiences and case studies had also got the opportunity to do it out in Bangalore.
Good.
And
Yeah.
associated with the company or other developers were the property development. And way back in 97, we developed a commercial complex, the shopping complex building at the Richmond Circle. Now it's called as Others Opus, where the lifestyle is housed. We were in discussion with the prospective buyers or tenants, and they had a challenge that okay, lifestyle wanted to enter into India for the first time in 1997, and they said we want the building within a year's time, and it should be completely as spacious as possible, being a shopping complex and all that. And we had a tough challenge to think about how to go about the whole thing. Okay, if we have to do it out in 1 year's time with a large plan structure, what would be the viability? And at that particular junction, how do we mitigate this whole construction activities? And while discussing with our structural engineers and architects, finally we came up with this concept of okay, let us try this Priestess of these slabs. And we did it at a 14.85 meters by 8 meters span. And at that particular time in 97, 98, there was the largest span structure in Bangalore used for a commercial slab. With a floor loading at that we had with around 750 kg per square meter as a floor loading at the time. This whole building was located at a very strategic heavy traffic junction. A single slab had almost 850 cubic meters of concrete. And since we were racing against the time, we started the Priestess concrete Priestessing contract also discussed with him how do we do it out. And finally, we arrived at the optimum grade of concrete as M45 so that I could do my stressing on the third day, go ahead with the descheduling on the 5th or 6th day. That was the biggest challenge what we faced during those days when we didn't have so much of extensive mechanization or manpower. The whole concrete, we used to schedule it out over the weekend on a Saturday, Sunday. We used to start on a Friday night, Saturday and Sunday for that particular traffic busy junction. And we did this continuous pouring. At one end, we used to start the concrete pouring, and on the other end, still the stressing work, shuttering, barbering used to keep on happening. But it was a fun and well-accomplished challenge. Thereafter, we went ahead. We have done a lot of industrial buildings with even floor loadings of 2,000 kg per square meter for manufacturing facilities, floor spans, and for majority of the hotel buildings, majority of the commercial complexes for parking floors, especially it gives a very good flexibility. Go ahead with the large span Priestess slabs. It comes with its own advantages, challenges, fun, but the cost is not very high to take it in terms of per square feet cost. The incremental cost could be roughly in the range of around 75 to 150 per square feet, depending on the type of loading and type of spans what we are talking about. So that shouldn't be a stopping factor when you compare the other tangible advantages and benefits in terms of time, especially when you're doing a commercial buildings or retail buildings, where faster occupancy would definitely lead to bigger revenues. So this incremental cost is negligible in those circumstances. With this adaptability, the flexibility, it's very widely used for all the large infrastructure projects use large spans, sleeker sections have been adopted without compromising on the performance aspects of it. There are a couple of questions which arise on this whole thing. One of the question is, are Prestressed concrete structures suitable for single span structures?
Pardon?
These Prestressed concrete slab structures suitable for single span structures?
Single slab.
Single span.
Single span. Slabs.
Yeah.
Yeah, why not? Why not? Single span is that it is a prestress in one direction. It is not a biaxial prestress.
Okay.
Yeah.
And how do we address this long-term deflection and creep? So in most of the projects, what encountered is because of this long-term deflection and creep, there are cracks which develops on the flooring. Initially, upon the completion of the project, we don't encounter that. But after 3 to 5 years, there are a lot of cracks which is there on the flooring which is laid over there. How do you address that?
See, this is where you are transferring the loads. You wanted strength in 3 days, strength in 5 days, and things like that. In prestressed concrete, you have to be careful that you control your losses. And if you delay, if you cure for a larger time period, you reduce the losses in some particular way, and that would help. So there is no use not giving the time that is required for this particular concrete in prestressed concrete. You have to give it the time. You have to plan that you can give that time. You can't do it like what you do in few days, few hours, things like that. Whereas if it is in a precast scenario, it's quite different if you are doing steam curing and things of the kind. In a controlled condition, most of the cases abroad, they are all factory made. There is a lot of advantage because they're all factory made, especially in Europe, it's all factory made only. So they have all this advantage that they can do steam curing and finish everything in 3 days, 5 days, and things of the kind. Whereas if you want to do the regular type of curing here, then your losses are likely to go up. That's what you should watch about. But the other aspect of you're saying cracking, that is quite serious. It is not due to this particular thing. It is more due to, I think, the shrinkage in the concrete itself. You have to see what crack it is and why the crack is. You have to see from a different angle. You cannot blame it on prestress. Yeah.
The crack was not on the concrete surface when we had stripped out the flooring which was done on top. The crack was due to the deflection which was there in the slab.
So obviously the deflection hasn't been worked out, and maybe the prestress there was a loss in prestress. So obviously there was more deflection than what is permitted, So it has failed in particular deflection only. Otherwise it will not happen. In fact, prestress is so rigid that you don't have cracks generally. My experience has been that you don't get cracks at all in prestressed concrete, except if you want to talk about shrinkage or something. Yeah.
Just one question from Mr. Ravindranath. Prestressed beams are designed for gravity loads and not for lateral loads. How do we overcome that?
Can you go over it again? I didn't get that. What is it?
Prestressed beams are designed for gravity loads and not for lateral loads. How do you overcome that?
No. That's a wrong impression, because if you have prestress all around the beam, you can take for any loading, whichever direction. Not that you should have only gravity load. You can have prestress on the sides and take care of the loads if there is any lateral loads. If he is talking about torsion, it's a different issue, because torsion you have to make it a separate design. for that. But lateral load, Priestess can be put in the lateral directions to take care of lateral loads. Not that only gravity loads should be applied. Yeah.
And in one of the case studies in the tennis court building, what you have done, you have specified that you have used fiber reinforced concrete while restressing.
Yeah, fiber.
As such, restressed concrete itself is a concrete of a good grade and control. What are the specific need of use of fibers?
The thing is that because of the difference in temperature between the top surface and the bottom surface of any slab, because it is exposed to the sun, exposed condition. So what happens is there in the body of the concrete there will be stick cracks which might come in because of the differential and the large span also. So if you put in fiber reinforced, that will even out all the stresses and not create any cracks within the body of the concrete. And the durability aspect is more durable than regular construction without fibers. Yeah.
In large bridges and cable stayed structures and all that, the biggest challenge is the strand corrosion and the corrosion due to chlorides. How do you overcome that?
Obviously, the covers that are being given to the tendons is one of the factors that come in, because the sections are getting slender and slender, and with finite element analysis and things like that getting into place, you're making it very critical. It's just adequate, but the workmanship, especially with respect to the cover that the tendons have, and the grouting. The aspect of grouting is a very important factor in flyovers and thin sections. So that is you have to take care of it by proper cover and larger cover. I mean, that's the only thing that you can do. And maybe the sections shouldn't be too slender. Yeah.
How is creep compensated in the retention tendons?
There's some echo in your distinct creep.
How is creep compensated in the pre-tension tendons? It's a question from Srikanth.
No, you can't. You can't. This thing creep is over a period of time. So what it says is that you load the thing after a long time. You don't load immediately. You don't pre-stress soon. In your case, like for example, 30 days after you pre-stress, then you're taking care of much of the creep. Or 60 days after, things like that. Or as they do abroad, it is a stage-wise pre-stressing. You put 4 cables today, 8 cables later, things like that. You could take care of creep in that way. Yeah.
What is the durability of PD structures with respect to ACCE structures?
Fantastic. Provided the concrete is done well, it is much superior durability. It's supposed to be a solution for durability. But if done well, that's a big gift. To give you an example, I saw in the distinct European institutions, the stipulations with respect to formwork are very rich. They have rubber gaskets, and they pour water into the formwork, and loss in 24 hours of water tells you whether it is safe or unsafe. We are getting to it, but we are not yet coming to that particular domain. So durability aspect depends totally on your formwork and how well you treat your formwork or how well you do your formwork. Yeah.
There's one question from Mr. Nirmal Rajamani, Dr. Nirmal Kumar Rajamani. What's the minimum grade of concrete, and is it higher grade of concrete always preferable? Minimum grade stipulated is M30 for post tension and M40 for pre-tension, and maximum grade is M60. But then can we go beyond that?
I want to say only one thing. He asked a very, very, very pertinent question to the right man. Because in my days of precious concrete, early days, I never used to stipulate anything less than M40. And I used to expect M40 would be 48, those days. It would never be like 41, 42 and things of the kind, or 44 as the code says. Now we are all talking so much. Why are the RMC people not giving you as per IS itself? Number one, when the situation is such with respect to a branded concrete, I don't want to tell you the name, but my client asked me that you should go to the Institution of Engineers and give a press conference and announce that these people are doing something like this, because he had no way to change the tender because his project would be delayed and things like that. And I told the people, RMC people, how can you send anything other than what is as per IS from your complex? And later my client had to put engineers to supervise the concrete that was coming to his project, which is a sad tale to all of us, because they all have a bad impression about civil engineers when something like this happens. Why can't we produce, when we say 35, why can't we produce 35? And then I heard, this is not checked by me, but I heard the processing people telling that in Hyderabad, they are already doing for M25, they are doing process concrete. I think this is very derogatory. Instead of trying to improve standards, going backwards. So I would say M40, but you better look at the RMC that is coming and take a call. If you want 40, if you have to stipulate 45, it's a very bad situation. You don't design for bad work, but you have to face reality. Priestess, you can't put bad work.
Having said that, okay, in this particular building, what I had executed, though our design mix was M35, we went for M45 basically to ascertain, to do a quicker stripping of the formwork. And we did this whole trial with the RMC at that period of time in 98 for a period of almost 30 to 40 days. We were doing a daily strength analysis for various combinations, and then we arrived at this optimum. On the third day, we are achieving 80% of the design strength, and then we can go ahead with the Priestess. But then why we have a limitation of only M60, or why not we use M80 or M100?
When you are not able to get a supplier to give you M35 properly, we are talking about much higher. But there are players who will give you that. There are players in the RMC who can give you, but these people don't go to them. It is like this thing, an auction. Whoever's all the people quote, and then you go behind somebody just because his figures suit you. That's not the way to go. You must see the track record of the person. This is what I asked. Where is this RMC person? Where has he supplied, and what are the results in the previous project? They came and they said, and I was shocked that in the previous project, people have accepted for M25 concrete, it was a 25.3 or 25.8 or something. It has been accepted by the consultants. I mean, the black sheep are here only. We are around us only. We are also doing things like this, which is not good. And if I had to do M40, I told my client that for 35, if I had to stipulate M40, it's a shame. What are we doing? Then he said, you must do something about it. The only thing I could do is come and tell everybody that the RMC is getting bad day by day, and I become a bad man. But it's not so. I appreciate the guy who puts in the effort in RMC to what we want. This is a common thing, and especially with PT slab, especially with Priestess beams, and especially in conditions which are different than normal, a large span and things like that. Yeah.
In fact, I would like to add that when we are doing these Priestess slabs, it's always recommended that the strand locations are marked on the soffit of the slab, so that whenever we undertake any services on a later date, it's always identifiable. Absolutely.
This is what I forgot to tell. But that is a keyword. I mean, that is fundamental. Because the drawings will be one and the cable may be something else. It can't be that way. So we must have some strict control over that. Yeah.
What are your views in the maintenance required for the PD structures?
No, I haven't seen any difference in maintenance because mostly you have a higher strength concrete and things like that. So you don't need anything special, but revisit once in 2-3 years, to get a touch up. In New York, I saw one of the masons coming with his overalls, and the project manager was with me, and I asked him what all is his overalls. His overall, he had a epoxy tube on the left side, he had a cement tube on the right side, and things like that. And I asked him, what does he do with the epoxy tube? He said, if he finds some crack somewhere or something where it should not be, he'll just take out his epoxy tube or something and seal that. So they take care of it right then and there, rather than wait for it, ask for a report, ask somebody to come and see. Good that they ask somebody to come and see, because many a time they can't recognize a structural crack from a non-structural crack. It has happened to me in many apartments where I've been called. It's a non-structural crack, and all these people are looking at the structure and saying the building is unsafe. This is what we've made of. So, that's a different domain. But you have to revisit at least during the project time. If it's 1 year or 2 years, some revisit in the different places and patch them up. Not patch by the old methods, by new methods. With the chemicals what you have, or the epoxies that you have, and things like that, and take care of it. I would say that. Yeah, that's it.
Bridges and offshore structures will require more maintenance compared to the buildings.
Yeah, everything has got something tagged onto it. So I see that even if you give a cement coat on a flyover, maybe once in 3 years or something like that, even a cement coat is supposed to be a protective coat. It is not for looks. It's a protective coat. Why do you put cement coat on the outside of buildings and structures? It's a protective coat. They don't do it even for the flyovers. They don't even give a coat after. The healthy thing is when you see it healthy. You must be able to see it as healthy. When do you see it as healthy? When you give it a coat, maybe it will close up a lot of the pores which are exposed, and it will be more durable, definitely. Yeah.
I have one last question to you from one Dr. Thereon.
Yeah.
Is it possible to use Priestess technology for larger pile from wrap slabs, 82-meter diameter wrap slabs supported by piles?
Why not? Why not? You could do anything with Priestess concrete, whether it's above the ground or below the ground. There is no. Only thing is that contact with the particular soil. It has to be ensured with the stress distribution in the soil has to be worked out, because I hear that it is not uniform stress distribution. It may be that some parts of the middle of the thing may be not in contact with the member. So things like that come in. But there is no reason why you can't do Priestess wraps and for Priestess piles. There's no reason for it.
And this one more last question from SKS. What is the importance of extension calculations to verify the Priestess force applied? This practice is not mostly followed to check.
I didn't get that word. Can you go over again? So echoing. Yeah. What is it?
The importance of extension calculations.
Extension calculations.
Yeah.
You cannot control the shade content of the stock. I didn't get this. Extension calculation of what?
It's not clear.
Yeah. Extension calculation.
At the end of the session, over to Mr. Srikanth.
Yeah.
Thank you the organizers. Okay, I think he has clarified it is elongation calculations. Thank you to ACCE for this wonderful arrangement, and thank you to Dr. Ram Prakash for his wonderful presentation and sharing on the practical views of how he has come across with various challenges and what are the features he has encountered and what are the do's and don'ts. Over to Shrikant. Hello Shrikant, are you there?
Sir, in online. Shrikant, sir, phone ಮಾಡಿ.
Is it audible?
Yes.
Sorry, my connection had disturbed. I have one small announcement to be made. Diksha, please, can you display the brochure, please? Yeah. Friends, now we had 4 weekly valuable series lectures by Dr. Ram Prakash, and we are happy that our members have been gained a lot of inputs from Dr. Ram Prakash, and we are really very much, our knowledge has been improved to that extent. Thank you, Dr. Ram Prakash, for your valuable inputs. And then similarly, now we have taken up the another series of weekly webinars starting from the next week itself, that is 26th September, with program leader by Dr. Ajit Sabnis on sustainable engineering series. We have got totally 10-week series. Apart from Dr. Ajit Sabnis, we have Dr. Kalgal, then Dr. M.U. Ashwath, then Engineer Kalbavi, and Engineer Rajkumar from Hyderabad. So we have got very good series coming up. Sustainability as of now, as per NBC 2016, is going to be a very prime, one of the important parameter to select the consultants. That is what the NBC says. We have to give a due responsibility, and that assessment of sustainability is going to become a part of the consultancy. So that is the reason we are taking up this series, and I request all the members to take benefit of this, and I would like to tell you that whoever attends this is going to get one certification at the end of the series. Thank you. Yeah, over back to you, Gopalan sir, for vote of thanks.
Thank you, Mr. President, Mr. Kannan, Secretary Shrikant, and all other office bearers for their efforts to host this wonderful session. Thank you to Dr. Ram Prakash for his valuable contribution that he has been sharing on various subjects, and he has covered this also very elaborately. And thank you to all the attendees for their patient hearing, and I appreciate your time.
Shrikant, can I say a few words? Shrikant, can I say a few words?
Please go ahead.
Yeah, thank you everybody for participating in this particular thing. Really thankful to everybody. Only thing I wish to say is that it is not the question of learning from these, it's the question of implementing from this. Whenever I hear a webinar or a lecture or whatever, I see what can be the takeaway to implement something. So if all of us can implement something on Priestess and encourage the companies which do Priestess, I think we'll have done our bit and also we'll have Priestess easily available to us in different applications. So I would thank the organizers for giving me this opportunity to say these few words. Thank you. Thank you, Mr. Srikanth.
Thank you, everybody.
Yeah, can we close?
Okay, sir. Bye. Anything is there?
Yeah, that's it.
Yeah, yes, sir. Okay, sir. Thank you. Thank you very much.
Yeah, thank you.
Thank you.
Diksha, when is this series starting? This sustainability series by our Dr. Ajit?
Sir, 1 minute, sir.
What is the date, please? Date we could not find out.
26 September, sir.
20?
6th September. Next week.
Fantastic.
Saturday.
And what is the time, please?
Yeah, from 4:30 to 5:35, sir.
Ravina. Hello, good afternoon.
Hello?
So it will be on a daily basis, or it will be a weekly 1 hour?
Basis, sir. Weekly basis, every Saturday.
Every
Okay.
Saturday
Thank you.
evening 4:30 to 5:35.
Excellent, excellent, Mr. Srikanth. Good morning, Dr. Ajit. How are you? Look forward to see your lecture. Thank you, sir. I'll sign out.
Okay.